Welcome to episode 6 of Hacktics and Telemetry, a Rapid7 produced podcast. I am one of your co-hosts, Douglas McKee, and with me, I've got the one and only Crypto Cat. He's actually serving two roles this podcast. He's going to be your co-host, and he's one of the researchers featured in the War Room with the one and only Stephen Fuhr as we talk about some Cisco 0 days that were discovered here at Rapid7. Stay tuned for that. Hey, if you like this podcast, if you've seen previous episodes, don't forget to like and subscribe. Leave in the comments. Let us know how we're doing. If there's something that you want us to talk about, throw it in there. We'll try to get to it in the next episode. We'd love to have some viewer feedback. Before we dive in here, Jonah, did anything interesting? Did you were able to make any money this weekend?
No, I wish. Some people did though. Pwn2Own was on last week. So
Pwn2Own, it's the Berlin one, right?
Yeah. It's at Offensive Con, and I mean the good news of this one is $1.13 million was awarded for 47 unique 0 days.
Come on now.
I didn't, not this time. I like to leave it for other people, you know.
Fair enough.
Yeah. But the bad news is not everybody got to show their bugs. So this is the first time in 19 years of the Pwn2Own competition that some people were rejected from actually showing their entries. So
too many bugs. Hold on, Jonah. This sounds like an AI problem. Is that exactly what we're doing again?
Exactly. And it just shows really how far this has come, right? Because we've had AI, we've had like these agents, people have been doing stuff with security for a few years now, but this is the first Pwn2Own. It's on a couple of times, it's on I think 3 times a year, right? Normally have like Germany, Ireland, and Japan. Like this is the first time. So it goes to show how much has happened over the past, 3 to 6 months, where now suddenly, and it's a shame because obviously if you spent like months working on something and then, you know, like, maybe the vulnerability you have is like unique, or the person who got in, you know, got a collision or didn't manage to get their vulnerability, or some people like miss the flight or like have to pull out. So you'd be kind of devastated if you'd like, you know, if you missed out
It's a lot of work and effort. It's a great competition, but it will be interesting to watch how it evolves over the years with the introduction of AI, which by the way, since we started it last episode, we will bring back the AI counter for episode 6.
We're going to have to hire more staff for this.
We might have to hire some more staff. So if you'd like to donate, you can always do that too. We'll hire some more staff to get some AI counters. Hey, Jonah, at least tell me this. Since you're the one that usually runs a situation room and looks at all the news for every week, did anybody delete their startup this week? Because I know that was a big one last time.
Not that I'm aware of, although there was another supply chain attack, Tanstack. Did you hear about that?
Supply chain attack AI, they're like, you know, all over the news every day. So which one's this one that you're talking about?
Happening all the time. To be honest, I don't really know too many of the details, but I did see that there was a dead man's switch in it. So basically, if you revoked the GitHub token that they stole from you, they would do like remove /RF
RMTech RF / that one of those classic hacks. Man, that's rough. You think you're going to lock the attackers off and you get out and you delete your repo instead?
Yeah, it's spiteful, right?
That's definitely a bad day. All right, Jonah. Well, let's for those that may not have seen the podcast before, we do split this into 3 main segments. The first segment is the situation room. That's where Jonah walks us through and talks about the latest and greatest news since the last podcast. And I think there's going to be some more AI and some more supply chain attacks because that's what seems to be hitting the news cycle these days. Then we go into our war room segment. This is our guest segment. As I mentioned a minute ago, our guest is senior principal researcher at Rapid7, Stephen Fuhr, who's going to actually worked with Jonah on finding a brand new Cisco 0 day in SD-WAN. So we're going to deep dive into that, talk about what's been going on there. And then lastly, we have our mitigation minute. Why do we do the mitigation minute? Because we don't want to just point out problems. We want to try to bring you some solutions. So Jonah and I will talk through of all this crazy news that we've heard. What are some things that you can be doing in your organization to combat the news on a regular basis? All right, please like and subscribe. And Jonah, are you ready to take us to the situation room?
Of course.
Let's do it. All right, here we are in the situation room where we promise to talk about AI all the time. All right, Jonah, to kick us off today, what are we going to talk about in the news recently?
We're going to start off with some non-AI content, so that'll keep you happy, Doug. Let me have a look. This actually just kicked off today. There is another supply chain attack. So I don't know, supply chain attacks might have to be added into the list of like things we shouldn't be talking about with AI, because it's just like
Not yet. Not yet, Jonah. I'm happy to talk about some supply chain attacks.
Okay, all right, yeah, a little bit of variety at least. All right, so yeah, this one kicked off today. It's a bad one, and where was the key info? This one hit 639 compromised package versions across 323 unique packages. All came out in this wave, and it was due to, I think, a single developer's or maintainer's account being compromised. The interesting thing, or the scary thing about this one really, is what it does when it gets in. So you can see here the payload targets, developer environments. It searches GitHub tokens, NPM tokens, AWS credentials, Kubernetes, Vault tokens, SSH keys. The list goes on and on. So it extracts a lot of stuff here, but it's not just that. If it can't extract this, it will also fall back to GitHub. So it'll actually use your GitHub token to create a GitHub repo so that it can exfiltrate your tokens to GitHub, and then it can just go to the public GitHub repo and download them all. So scary.
So if you say that's because one account got compromised on GitHub, is that what you had said?
Let me just double check that. I believe it was. I'm sure I saw that earlier when I read
is this connected to the Team PCP thing?
I don't think so.
Because I thought that was interesting this week too. We've seen while you're scrolling around there, because you said I can't pronounce it, so I'm probably going to fail here. Yeah, right in the middle of the screen there, Shy Huld campaign. That was related to Team PCP open sourcing their supply chain worm. I just didn't know if you knew if this was connected, because that's pretty quick turnaround if it is.
There we go. It was. Let me see. The attack effects packages tied to npm maintainer account a tool sockets internal review. So yeah, it was tied to so a single maintainer account. But that's not even the worst of this, Doug. It's pretty bad, obviously. That's going to extract all of your tokens. It's maybe going to create some GitHub repos, so then your stuff's public as well, unless it puts some kind of like credentials or like a private repo setting on that. But it's also wormable. So if it discovers an NPM token on your system, it's also going to deploy the malware to another NPM package. So it's just going to keep going.
We haven't had a good worm, I don't think, in a little while. That's pretty crazy that we've got something wormable. And I do think it's worth calling out, because it seems like it's relatively connected. There is a threat actor group, our hacking group, right, called Team PCP, that announced, I think it was it last week? I think it was last week that they were open sourcing.
I find it hard to keep up, because between Team PCP and Shiny Hunters, it seems like they're in the news every...
Yeah, exactly. It does. It seems like they're in the news every week, but they open source the full source code for their worm, which it looks like is what's being leveraged here as well. And like, that's kind of crazy to me to think about, right? So like, we as a developer community, as a researcher community, we think of all the time of all the benefits of open sourcing code, right? And everybody can use it. But hold on, let's just flip that lens for a second and say, when threat actors start open sourcing their malware that other threat actors can leverage, I mean, you start to see stuff like this, right?
I missed that. Did they do it intentionally? Did they like say, oh...
Yeah, they intentionally open sourced it. Hold on, maybe I can in real time here find the article for you.
I'm struggling to see the benefit to them.
I found one of them. Let's flip the script here for a second, and let me share my window here, because I do think these. It's interesting you brought this up, because I do think these are related. So this came out.
It is, yeah. Shai Halud. That was the article I just shared. So this was like another wave of that attack then.
Yeah, I think what you shared was probably step 2 of this, right?
Okay.
So yeah, I mean, this sums it up here. Uses ups the game by releasing the source code. Talks about the code was shared via GitHub repositories under several users and accompanied by detailed instructions on how to use it. And I believe there's one place in here. So they're trying to get more
challenge.
Yeah, exactly. They're trying to incentivize threat actors to leverage to leverage this source code. The only reason I caught this is we talked about it in the Monday brief that we released on Monday in the newsletter that I send out. And so I think it's hilarious that you're bringing up the byproduct of that is the article that you're talking about, right? So what I think is really interesting in the fact that we're seeing this is I think we're going to see more of it. Like I think when threat actors open source their toolkit, then you get more script kiddies that can jump in. You get more, obviously advanced groups can use it. I'd be interesting to think if I'm an advanced threat actor, if I would choose not to use this source code in some aspects, because I'd want to come up with something that's less likely to be detectable, maybe. But the argument, the flip side to that is all you got to do is modify the existing source code, and it's harder to detect. But
true, and also I guess like if you're another threat actor, you probably want to do a very good source code review of this before you start using it yourself. Don't use it yourself, obviously. I'm not encouraging that.
But speaking of source code review, maybe there's some AI models out there that could help you do that source code review that threat actors are leveraging, which I think brings us right to the next point. Jonah, which model would they use? If you were a threat actor today, which model would you be using?
I guess it depends what model I can get my hands on.
That's fair.
And which one I can afford as well.
Are there any statistics that show which one might be better?
Yeah, let's take a look. So we have a new research paper out, or a new article out from XBow. So a regular feature of this podcast because of all, obviously, the stuff they're doing around agentic AI. And yeah, they've been testing out Mythos. So Mythos for offensive security evaluation. This is obviously the new model everybody's been talking about. And they tested the preview. What's the takeaway here? So yeah, they said it's a major advance. It's a powerful tool.
Hold on. I like what it says in the middle of the screen right there. It's not magic, though. You see that? You see that?
No,
it's not magic though. A model is a brain without a body. I think that's a key takeaway.
Yeah. I got you. This is the takeaway. While the source code audits are good, okay, the takeaway is a bit short. Let's go and have a look at some of the actual results. So I think this is a nice chart which talks about some of it. Cuts false negatives in half for web benchmarks. So they have their own benchmarks set up. And I believe also, actually, one thing that I did miss there. So they compare this to Opus 4.7 and GPT 5.5, obviously some of the models that people are playing around with at the moment. They were looking to test the model's judgment with regards to threat modeling, vulnerability validation, and safety. Its ability to read source code versus interacting with live systems, very interesting topic at the moment. And its ability to find exploits we're not yet looking for in standard assessments. So native app vulnerabilities. They also mention here that you have Mythos in terms of the raw model, and then you also have it like inside Claude Code as well. So they wanted to evaluate both separately because they use obviously the raw model with a lot of their custom kind of agents and tools and whatever kind of harnesses they have set up there. So it's quite hard then to benchmark stuff, right? If you have all these different companies, they have different harnesses, they have different skills, they're all using these different approaches with the same model. How do you really know which model is better? It could just be the harnesses playing a lot. So I like that they're actually separating those and trying to test kind of one in its raw form and then one with its like more thought out kind of tool set.
Yeah, I like this chart though. Let's go back down to this because I think it's interesting. For me, the negatives stand out more than the positives because everyone keeps talking about, it's so good at everything type thing. But I really like the command safety and the threat modeling takeaways here where it's quote unquote mediocre and fair at best. What do you think about these categories?
Yeah, command safety, technically right, but practically wrong. And then I think, threat model, fewer false positives, more false negatives. I mean, that's interesting. I think one of the other research articles we're going to look at was actually kind of talking about how they specifically tune their system in a way that they're prepared to deal with a lot of false positives because they really don't want to miss a false negative. So
that's what I was thinking. I would rather have a few false positives. I don't know which way works better.
I guess it depends. I mean, it depends if you have like millions of false positives to like one false negative. Maybe like you might miss that false negative anyway. Or, you might just have so much to deal with that it's kind of hard to process anything. I guess it depends. But if you have like you don't want a false negative of like some crazy auth bypass like we saw on the SD-WAN recently.
That we'll be talking about in an upcoming segment when we bring on Stephen, our other researcher for that project. But to your point with the false negatives, and nobody has this stat, so it's probably impossible to quantify, but it would be interesting to say, okay, sure, it got more false negatives, but how does that compare to if you only were using humans? How many false negatives does your average researcher generate compared to how many false negatives is your AI model generating? Which again, I don't think that's measurable, but it's a really interesting thought.
Yeah, very true. Very true.
What's another pretty graph you got?
Yeah, another chart here. This is just comparing the benchmark on. So they gave it a case where it has to get a POC on it against a vulnerability after a series of 80 actions, which could be like running a command or a Python script or some kind of tool. So this is just comparing the different models. So you can see Mythos preview has gone way above Opus 4.6 and even GPT 5.5, which has kind of been getting a lot of talk as well. Way above Gemini 3.1 Pro. I don't know, are Google going to come out soon and just like surprise us all with some crazy model, or are they going to
Google what do they call it? Don't they have that big sheet model? I think it's called but
Okay.
we haven't seen. I don't think it's been. Hold on, let me.
Yeah, I haven't heard as much talk about that for sure.
You keep going. I'll Google it.
Yeah, a couple of stats there. So compared to the latest model, Opus 4.6, it reduced false negatives by 42%. And in a variation where it had the source code, it even cut it by 55%. And this is one thing that's really interesting about this, which I haven't seen kind of talked about anywhere else, is I've seen some discussion about, GPT 5.5 being kind of particularly good when it comes to like black box testing compared to Opus being good at white box testing or source code review. But they actually used Mythos Preview. They did it with source code only, and they got 58% as the results. They did it with live only and no source code and got 92%. So that's crazy. It's like over 30% difference, and it doesn't have any source code. So we're being told like, oh, this is so good at like finding vulnerabilities in source code. It's actually better at finding vulnerabilities without source code.
That's absolutely incredible to me. It's definitely more intuitive to feel like it would be reversed.
Yeah, for sure. Did you find that, Doug? There was another part here.
I think what I was thinking of, it looks like back in 2024, actually, Project Zero released this module, it says it's Big Sleep, by the way, not sheep. I don't know where I got sheep.
Okay.
But Google's Big Sleep is an AI-powered cybersecurity agent developed by Google DeepMind and Project Zero, originally called Project Naptime. The system is designed to mimic the workflow of human security researchers to independently discover, analyze, and patch zero-day software. At least that's what Google's telling me about Google. So that's probably what I was thinking of. But it looks like that model's pretty old at this point.
Yeah, I'm sure they'll be working on something. I would be surprised if they're not. We talked there. This is what I was trying to find there, Doug. You mentioned the command, or the memory safety bit, or the command execution part.
Yeah.
There was a specific part about this down here. So they said the judgment results were more mixed than the discovery results. Across command safety, threat modeling, and trace triage, it was often careful and precise, but also literal and conservative. So it rejected false positives better, but also lost the true positives. So kind of what they were saying there. One bit that shocked them particularly was the performance on the command safety benchmark, where they asked the model to consider whether a given script is safe to execute or not. And they hand-labeled it. They gave it some different models. Haiku 4.5 gave 90%. Opus gave 81%. Mythos gave 77%. So it's actually a drop. That's not that big of a drop, I guess, though.
So hold on, though. You got to back up, because it starts with Haiku, or however you're supposed to pronounce that. That's supposed to be, quote unquote, the dumbest model.
Yeah.
And that one got 90% accuracy. So I think what's interesting is the discrepancy. Yeah, the drop from Opus isn't that big, but Haiku is supposed to be not better than Mythos. At least that's my understanding of the way they're supposed to work. So that's pretty crazy. For
sure. And I think there's another part here they actually mentioned at the bottom. We should note that Opus 4.7 shone above. Oh, no, that wasn't the bit I was looking for. There was some part on this I thought where they said they didn't use, or maybe I might be confusing this. There's too many AI research articles coming out. It might be the next one.
All right, well, let's take a look real quick at one more, since that seems to be the highlight for the week, is because as Mythos gets more time out there, we're getting more and more reviews. And I believe the other one that you found had some pretty interesting methodology for testing, right?
Yes. This one is from Cloudflare. So same thing, they got access to Mythos. They did a bit of a review about how it worked for them, what their findings were. And maybe this was the one. I'm going to search Opus 4.7. No, okay. I swear there was, it must have been the last one that I couldn't find somewhere, but I think, Opus 4.7 is quite different to 4.6 in the way that it works. So I know that some companies have been like leaving it out of the benchmarks and not really comparing it to Opus 4.6 and GPT 5.5 and stuff like that. So yeah, this is from Cloudflare. I think there's a couple of things here. I'm going to skip over quite a lot of it. I thought it was interesting here that they say that the model refuses legitimate vulnerability research. So they were specifically given an unlocked model, which is supposed to give them, full access, but they still ran into these problems where it's saying, I can't help you with this. You're asking me to find a vulnerability and then actively exploit it against live infrastructure. So even with like an unlocked model, they're still having problems like this. So I mean, what sort of issues are the rest of us going to have? So it actually, well, in this case, they said that they got around it by making a slight change to the environment. So they said it initially refused, and then they made an unrelated change to the environment. Nothing in the code changed, and then it just worked after that. So sounds sounds like it has some intimate issues with like the kind of safety guardrails in place. Yeah, I think one of the big takeaways from this one though is this why pointing a generic coding agent at a repo doesn't work. So, this is the idea that you can just kind of hook up one of these models and just say find all the bugs and it will find them. Quite often it will find bugs, and they all get better at doing that. And particularly Mythos are saying, is a step up in that arena. But it's the harness that they're kind of emphasizing as the important thing. So they give 4 lessons that came out of running this Mythos model. They said, narrow scope produces better findings. So like what I just said there, don't just like say find all the vulnerabilities. You want it to look for a specific vulnerability type, or you want it to look at a specific function, a specific file, something like that, and basically just like repeat that process. Kind of like that. Remember we looked at an article on Needle in the Haystack, LLM vulnerability research. Basically the same kind of principle that they're applying here.
I think that's not vulnerability research specific. I think we've seen that with these AI agents as they've come out, is sometimes less is more. In the context of that includes scope, right? Like the more you focus the agent on a very specific task with specific guardrails, they seem to perform better. I think we continually find this.
Absolutely. And I think from that, the last one, the Haystack one as well, they specifically said like, you have to tell it there is a vulnerability here, even if you don't know there is one, if you don't say, if you like say, oh, find all the vulnerabilities, or is there a vulnerability here? It's just going to go, no, I've had a look, there isn't one. But if you say there is a vulnerability here, you're not going to sleep until you find it, then it might find it for you. The next point, adversarial review reduces noise. Another thing comes up quite a lot is adding a second agent, particularly like a second model. And we've seen this with some like other projects. DeepSec is one that I was looking at from Vercel, where, you run it and you can run it with like Opus 4.6, 4.7, and then it actually has a specific option to like revalidate. And they recommend doing it with another model. So then revalidate with GPT 5.4 or 5.5.
That's
and it
similar
reduces
to the whole contrarian concept too, right?
Yeah, exactly.
Yeah.
So you want 2 agents in disagreement.
So for viewers that might not know what that means, it's setting up an agent deliberately to argue with the one that has the finding and say why it's not true. Effectively, you can correct me if I'm not describing that right.
Yeah,
Jonah,
but I think I was actually thinking, a lot of people make these like agents and skills, and they say, oh, like you are a security researcher, or you are a bug bounty hunter, and you find like 100 bugs a day. They give it this kind of prompt, so you could just have an agent, and it's like this is your prompt, and then the other agent, a different model, is like you are a bug bounty triager. Your responsibility is to filter out all invalid reports, and then you basically just let the two of them work it out.
Duke it out.
What else do they have here? Splitting the chain across agents, so splitting up into different agents, and asking different questions. So saying like, is this buggy compared to can an attacker actually exploit it? Very different questions. So you might be better off splitting them into different agents.
That's the whole narrow task thing again. Keep the scope really narrow and guardrailed for each agent.
Exactly. And that's the last one. Yeah. So coverage improves when many agents work on tightly scoped questions. So all great ideas to put into practice, and they even give like a diagram here showing exactly how the harness was structured and a breakdown of each step. So if you were looking to try and put some of these into practice, I think this is not a really good article to learn some lessons from.
Absolutely. And by the way, I did look it up in the other article while you were talking about Opus 4.7. So XBow had said that the chart that you showed with odds of finding a vulnerability, where they had the Mythos preview much higher than everything else, you'll notice in that chart what's missing is 4.7, and
that's where they skipped it, right?
Yeah, they have a footnote there that says we haven't included Opus 4.7 in this chart because the model interacts with our system in a unique way, making this particular stat less relevant. And then they have a link to where they've written up the full story on that. So it's just to your point.
We covered that before. We did cover that before. I'm losing track because we've covered so many from so many different companies. It's all kind of blurring into one big research article now.
Yeah, but I think that's a good wrap on what we've seen since the last podcast. A little bit comparative some models as Mythos continues to mature and get more information released. And let's not forget about those supply chain hacks, because hey, when threat actors open source their framework, it's going to get used. All right, so with that, we're going to move over to the war room, where we're going to actually still deep dive into a 0-day vulnerability that Jonah here had participated in, and we're going to grab Steven and throw him in and talk about the latest and greatest 0-day SD-WAN vulnerability. See you there. All right, welcome to the War Room, and I am super excited this time to be bringing on our very own, who's also normally a host, Jonah, and our very own researcher, Stephen Fewer, to join us to talk about the latest and greatest Cisco Zero Day. And the reason we're bringing on these two gentlemen is it was actually discovered here at Rapid7. So it's got a really awesome story to it. I think our audience will be interested to hear how you guys collaborated together. And hold on, I don't know, do we have a counter this time, Jonah? Are we talking about AI again? We're supposed to be limiting our AI talk, but there was some AI component to this as well. So let's go ahead and dig in. First of all, I don't know which one of you want to start, but hey, why don't one of you give me a little bit of the backstory here of how we even got started looking at Cisco to begin with?
Yeah, sure thing. So Jonah and I are on the same team. We do a lot of similar research. And one of the things we do on our team is Rapid7's Emergent Threat Response Program, where we react to high-profile vulnerabilities. And around late February, there was an advisory for an exploited in the wild auth bypass affecting Cisco SD-WAN controller. And we ETR'd this. And that led us to do some end-day analysis to try and find out, what that actual vulnerability was, how it worked, and with the goal of ultimately writing an exploit. So that's how the project began. We started digging into this end-day back in late February. And yeah, it was interesting because the threat actor was exploiting it in the wild. Cisco's Talos group reported them as being, a highly sophisticated threat actor, which usually is kind of a subtext for like a nation state aligned or affiliated threat actor.
Exploited since 2023 as well, I think it was, Stephen.
Yeah, that's really interesting, right? Is that huge delay that they were actually sitting in the SD-WAN fabric of some organization, probably, a high-profile organization. We don't know who the target was. But yeah, since 2023. So that rings a bell for, like a highly sophisticated threat actor is a reasonable call out there, I think. And an interesting target that they would, have that capability and have it for so long. And no one discovered them until just recently, basically.
Yeah, I think that,
so that's the kind of target you want to look at.
Absolutely. I think the target here is one of the more interesting aspects to both these vulnerabilities, talking about the one came back in February. But if we think about from a organization perspective versus a networking hardware perspective, if you will, over the last decade, right? The idea of consolidating things to a single resource to be able to manage these software defined networks, which is really interesting concept to begin with. That centralization and that management plane becomes very, very interesting to threat actors. And it's crazy to think if someone has been like, extrapolate that out for me for a second, Stephen. If someone's been in your network backbone since 2023, what type of stuff does that give them the potential to do?
Yeah, exactly. That's the big question. I mean, if you're in the SD-WAN fabric, first we got to talk a little bit about what to use SD-WAN for, who's using this. And it's software defined wide area networking. And it's used to kind of glue disparate networks and topologies together to build out large, complex enterprise environments or enterprise networks. That can be, multi, across different geographies, different kind of networks, can bring in cloud components, and it can kind of glue all these different things together. So if a threat actor is in this fabric and has the ability to move through it or reconfigure it, they get access to everything. They're deep inside the very kind of core networking component of these complex organizations. And the interesting kind of aspect is, who are the kind of organizations that even need this capability of SD-WAN? They're big government organizations, government, state bodies, large, multinational organizations that are around the world. They're big targets to begin with because they have that requirement for things like SD-WAN. So yeah, so if you're embedded in someone's SD-WAN fabric for several years, you're everywhere that their network touches, basically, potentially at least.
I don't know if
at a network level, you can put yourself in a position to man in the middle or to sniff, or you get access to some really low level capabilities for a threat actor. That's cool.
I don't know if you like this analogy or not, but I almost think of it as like domain admin on a different level, right? From an attacker standpoint. One of the things that I teach for SANS and the exploitation class is how powerful it is to get control of routing and networking and to be in that machine in the middle position. That's our goal, because once you get in the middle of devices, you have a high probability to be able to control traffic, control where it goes, inspect traffic. There's everything that goes with that is extremely valuable for an attacker. But hey, Jonah, I know you're not used to being as part of someone that's actually being interviewed on this show, but I want to get you involved on this because you were a very important part of this research project as well. So we've been talking about, we actually mostly been talking about this older vulnerability, the one that threat actors have been leveraging from 2023. But then when this actually came to light, it's what prompted us, or prompted you and Steven, I shouldn't include myself in that, to kind of dive deeper into this and say, hey, what's going on here? So can you clear up for our viewers, our listeners here, what is the difference between the two vulnerabilities, the one that was the original one that was released and the one that you guys discovered?
Yeah, for sure. They affect the same component, but there are some differences to them. I think it'll probably be easiest. I know we don't have everybody with access to the screen, but I'm also just going to share the link, or I'll share the screen for the exploits, so we can just have a quick summary of the differences. I'll just mention as well that, this was late February. I'd only joined Rapid7 a couple of weeks before this kind of came out. So at the time, I was still tripping over setting up some of my debuggers and patch analysis tools.
Immediately, though. Look at this guy coming in a couple weeks.
Jumping in the deep end, right?
Yep, killing it with some new 0 days.
Yeah, so it was all moving pretty fast. So this is the first one. This wasn't actually the vulnerability that we discovered first. This was the vulnerability we were trying to discover. And it was only a couple of days after that we kind of realized, oh, we need to go back because this still works on the latest version. And this is how the previous one works. So basically, you have this, here's a standard benign peer inflow and a malicious one. So the handshake starts, you have this certificate exchange. It should obviously be a valid cert in the benign situation. And then, so let me just go through the benign one first. So the server sends a challenge, which is a type 8 message. The peer will respond with a challenge ACK, type 9, and then the server's going to verify that signature, so the cert that went through at the start. And then once that's confirmed, everything's okay, it's going to go back with the challenge ACK, which is a type 10, and that's it. Peer is now authenticated. So pretty standard authentication flow, right? You've got this handshake, that should all go smoothly. The problem arises when the attacker decides to skip the challenge ACK. So you still have this handshake at the start, but it doesn't actually matter whether the cert is valid. It can just be self-signed or a bad certificate. The server will send the challenge. The attacker's supposed to send the challenge ACK, but it doesn't. So that means the server just doesn't verify the crypto signature. There's no RSA verification. And that means that the server's not going to send that challenge ACK message, the type 10, which means the peer is not going to be authenticated. But the attacker can just send that message to themselves. So the type 10 message is sent to themselves with this verify status bit set to 1, which is part of the packet that's sent across. And from there, it flows through to the point where the server sets the authentication to true as well. So yeah, they bypass the whole authentication.
It's pretty ridiculous, right? The attacker can just choose not to authenticate effectively is what you're saying here. Now
Exactly.
Does this hold true for both of them, or is this the original 0 day?
This is the original one. So this is the end day that we were looking for. This is not the vulnerability that we're just disclosing. So let me actually swap over to that one.
Yeah, because I think we even talked about that on one of the first podcast episodes, if I'm not mistaken, as we brought this one up. And so I think it's interesting now to see the evolution, X number of weeks, months later. So that was the original end day that was released back in February that attackers were leveraging for 3 years or so, is what was discovered. And this is what you guys found.
Yeah, so this is a different one. You still have this certificate, this handshake, but it can be any cert that goes through. You still have the challenge, so the server is sending the challenge. The attacker, in this case, responds with the challenge ACK, so they're not actually going to skip that this time. That's the big difference so far. But whenever they send that, they're sending it with the device type set to 2, and that is this vHub device. And basically, as you flow through the rest of the if statements, there's no verification steps performed for this device type. So it goes through, the server sends back the challenge ACK to the attacker, and then the attacker just needs to send a hello message, and that's it. They've passed the authentication. And I think if we scroll down a little bit, here's the devices. So yeah, if you look at there's the vEdge, the vSmart, vBond, vManage, ZTP, these are all fine. I believe there is a summary somewhere of the verification. Yeah, so if you have this device type 1, it's going to verify the hardware cert, challenge certificate, board ID, OTP. If you have 3, it's going to do the cert chain, serial lookup. So all these are doing what they should, but if the device type is 2, it's just going to fall through. There's no verification steps along the way.
Yeah, it's crazy to think we still find code in 2026 that's just not doing simple verification, right? And that's what most mitigations are. If you, for example, if you look at the Microsoft ecosystem and how they've evolved their mitigations over the last decade, most of them are just verifying assumptions. And that's effectively the same thing that you guys are finding here, is that there's assumptions being made. Assumptions are bad, and we're not verifying that things are actually the way they're supposed to be. And then we can, or I shouldn't say way attackers can leverage that to their advantage in this case. So Stephen, I know that as part of this research, you really we keep exploring at Rapid7 on the Vol Intel team different ways to leverage AI from a vulnerability research perspective. And Jonah, I can't seem to stop talking enough about it on this podcast. But I do think it's a really interesting story to hear a little bit about how did AI play a part in this vulnerability discovery of this 0 day?
Yeah, absolutely. I mean, we're seeing AI advance so quickly in the last few months, and its application to vulnerability research is so increasingly profound. I mean, we're constantly seeing week by week the advances and the impact it's having in our field. So we're absolutely leaning into it. We're building out workflows and tooling to do this. And this project was a great example to actually leverage some of that and see what we could achieve. See if could we find 0 day, can it do end-to-end analysis, can it do exploit development, and get some kind of concrete examples of success in this area. So yeah, for this project, we absolutely leaned into AI. We kind of set it up that we had an agent with access to the unpacked firmware for a vulnerable version and a patched version. And we were manually diffing this out too, so we could look through the diff. And the diff in this example, or in this case, was somewhat confusing because they had patched the vulnerability. When we're talking about the end-to-end analysis, the older February vulnerability, they patched that out. It was in some binary code in something called the vdaemon service. And we could see that, but we could also see several other things that they also patched out due to, we think, maybe a local privilege escalation and a few other kind of non-related issues to the CVE we were chasing. So one of the advantages with AI is you can just point it at the diff and the whole code base, give it some prompts and say, go look. But you can also feed it things like IOCs had been published by Talos, for example, which give clues because the IOCs give logs, log files, snippets. And those log files are generated via, the binaries, the vdaemon binary, for example. So the AI can easily correlate the IOCs that were published back to where some of the diff was happening and hone in on where the actual root cause was. So it let us move really fast to actually locate the vulnerable code area, but then also once it identified the issue and correlated that to the actual CVE we were chasing, because often it can be, if multiple vulnerabilities get patched, it can be there's extra work involved in kind of disambiguating which vulnerability you're seeing in a diff, especially when the diffs are messy. But this let us go further that we could also, and Jonah touched on the flow of the messages, but this is like a custom binary protocol over DTLS, which is like TLS over UDP. So the agent can just pull this apart. It can read through the binary. It can extrapolate what the protocol looks like. It can start building out like a Python POC to communicate over the protocol. And this lets us move and iterate really, really quickly. We don't have to manually do this kind of work. We can quickly kind of start sending data, start communicating with the target service, start hitting breakpoints and, start hitting the vulnerable code. Yeah, so it was pivotal to let us move fast, I think is probably the best way to put it. And ultimately, we were able to use our AI workflow to correctly identify the vulnerability, build out a working POC and test it sort of, end to end. I wouldn't say it was fully like one-shotted. This was through a workflow where we were prompting and we were iterating and, moving kind of with, I think the phrase is human in the loop. It was how our workflow is. But it did let us move very, very fast. And it's a great way to, use this tool to assist the research. It's very good.
Yeah, that's pretty awesome. But I've got a couple points that came to mind, right? When you're talking through the workflow and the different processes. For one, I think it's really interesting that you brought up like human in a loop, right? So I think the AI, based on your analysis here, wasn't doing anything that you and Jonah couldn't do. Right. It was iterating the same steps that you would do as researchers, and you were pointing it in that direction to do these steps. In fact, unguided, it may not have found as many things as easily as it was because it had two experts kind of guiding it in the right direction. And it's doing the same thing. It can just do it faster. So that's that whole machine speed versus human speed. So I think it's a great tool from that perspective. Another curious question I would have for you, and I think it might be interesting to our viewers, is we hear a lot about how well AI is analyzing source code. So when it actually has the code, right? Here you're talking about reverse engineering firmware. So like what language was you think you called it the vdaemon binary? Like what language was that in? And were you providing decompilation? Was it doing the decompilation for you? Was it looking at assembly? Like what was it looking at to do that analysis?
Yeah, sure thing. So yeah, in this case, the vdaemon is a native code binary. So it was decompiled prior to, passing it over to the agent. So the agent did have access to the decompiled C code, but if it didn't, we could have engineered it so, given it like an MCP server to a decompiler, and then it could have just gone off and decompiled what it needed to. As we laid it out, we gave it access to the root file system of the the actual firmware, but also we went ahead and decompiled the binaries we thought were sketchy based on our initial analysis of the diff.
Yeah,
but
so
I have no doubt it could have done it itself. And in other examples, I've seen it just pull apart binaries itself. And even if you don't give it a decompiler, I've seen agents just start to read the disassembly, like with object dump, and just start reasoning about the disassembly and reconstructing pseudocode from that. So, you can make it move faster if you provide better context up front, basically. And speed is the name of the game here. So
that's what I was thinking, is you guys provided a lot of context, because you also just said part of what made it so effective is you didn't give it all the binaries. You knew exactly which ones were interesting and you gave it those specific decompilation. Not that it couldn't have done it the other way, but by making it targeted, again, leveraging your expertise, it was able to do things even more efficiently than if you hadn't provided it that expertise.
Just to jump in there as well, not related to this project, but I've also done some stuff around like reverse engineering, not even with the MCP server, but you can like Copilot or Claude or something like that can sometimes just use like object dump and point at like interesting functions that it wants to review, and then it'll write you a script that you can just put into Binary Ninja, and it will like decompile it all, and you save all those files, so you're burning less tokens because it's not like trying to like work out the assembly itself, and it's not like constantly extracting more and more stuff. It's basically giving you the script or the tool to go and like just give it all the information, the high value information that it'll be able to use to go further. So I mean that wasn't needed in this case, but I have used that on other projects and had quite good results.
Tokens, it's all about this tokens, man. We're burning tokens like nobody's business for sure. But thinking about this, going back to this specific 0 day, I think one of the interesting things that came out when we released the 0 day was that it was actually also exploited in the wild. Tell us a little bit more about what we learned, that the 0 day that we discovered was being leveraged by threat actors, even potentially before we released our disclosure.
Yeah, so I mean, this was disclosed last week, and at the time of disclosure, Cisco notified, in their advisory, stated that the new vulnerability had actually been exploited in the wild. They stated in their advisory that they detected this around May, which is after we disclosed it privately to them in early March, but before public disclosure last week. And I think that's interesting. In Cisco's advisory, they also attributed the exploitation in the wild of this new 0 day to the same original threat actor that was exploiting that end day we analyzed back in February. So that same threat actor that was, as Jonah mentioned, present for several years in whatever target organization they were compromising. So it's interesting to think of how, threat actors can quickly pivot to a new capability to regain access or to maintain access, and how you're really fighting an uphill battle there, and how quickly, and we don't know if they're using AI or what capacity they leverage it. The speed at which you can find new vulnerabilities makes it challenging to patch out existing ones and kick threat actors out, because they can just switch up and find a new vulnerability or leverage it. So yeah, I think that was an interesting development, the fact that this was exploited in the wild prior to disclosure last week.
Yeah, and I think Cisco's up to 6 0 days in the SD-WAN software for 2026, right? Which just also goes to like focusing on once threat actors or once researchers, it doesn't really matter which, find a bug in something, they often keep digging in, because the unfortunate reality is where you find one, sometimes you find two, and et cetera, et cetera. And it's complete conjecture because we don't know for sure, obviously. But there's a hypothetical scenario where maybe the threat actors knew about both of these before we did, right? And they used one and then they pivoted to the other one as soon as they started patching the original vulnerability in the SD-WAN as well. Maybe they've known about all 6 of these over the past 2026 and pivoting it through. But I think one of my perspectives on that is really important is I think it solidifies the need and the continued focus put on defenders. We like to think of ourselves as offensive researchers, but honestly, we sit in the defender camp, right? We're doing offensive research for defensive purposes. So I think it's really important to continue to do that vulnerability research and to continue to leverage the tools that have been provided for us, because quite honestly, and again, this is conjecture, there is no evidence to support this one way or the other, but we hadn't reported this vulnerability. Maybe it was not detected that this was exploited in the wild because we hadn't pointed out that it was there. And who knows, maybe it would have been another 3 years that these threat actors could have sit inside of these SD-WANs and potentially grab the valuable stuff that we were talking about. So, I joke sometimes in my SANS class when we're talking about advanced topics like fuzzing or we're talking about vulnerability research, and someone comes up and says, why should we do this? We should do it because the bad guys do it. And anything that they're going to put the effort in that they find value, then we need to make sure that we're leveraging from defenders to be able to provide the knowledge required to protect against these things and test against it. And actually actually, speaking about testing, Jonah, I know that once, we got all the technical details here, we were working with Cisco, being that we work for Rapid7 and we have an intimate love for the Metasploit platform. I know we started working on a Metasploit module for this, and I believe you did a lot of the work on that. Kind of walk us through. I think, again, there was some AI involvement in the Metasploit module, and I think there was, we've released that Metasploit module. Tell us a little bit about that process and specifically how it relates to this SD-WAN vulnerability.
Sure, yeah. So me and Stephen took turns on this one. Stephen did the first Metasploit module, I did the first analysis, and then he did the second analysis, I did the second Metasploit module. So yeah, both the Metasploit modules are available now. That's it. And yeah, I've been using AI for Metasploit module development. Like, I've been trying to integrate it into most of my workflows. I have found it to be very good so far. I'm trying to, as much as I can, go based off of feedback from the peer reviews in the past, the pull requests. So obviously Metasploit, the framework, is a community project. You can go and contribute. You can make your own modules for it on GitHub and stuff like that. If you do that, you're quite often not going to realize that it's a very long-standing project, and there are various small Metasploitisms which you're not going to know about until you've made a few modules and had somebody push back and say, oh, you need to do things this way, or you should have done that here. So I've basically tried to integrate a lot of that, because all that feedback is public on GitHub. I've tried to integrate that as much as possible, along with the documentation that Metasploit comes with, and obviously all the modules are open source. So you can basically just compile that all into one and try to develop an agent and skills and references, so that whenever you want to go make a new module, hopefully you can just take the POC that you already have in Python or your language of choice, and basically just say, I want to put this into a Metasploit module, and it's maybe not going to one-shot it, but you can probably cut 80 or 90% of your development time. Some of these Metasploit modules have thousands of lines of code, so
it's pretty neat.
That's awesome.
Yeah, go ahead, Stephen.
Yeah, I was just going to kind of lean into that, because Metasploit is, from a module development perspective, it's reasonably pattern-based. When you exploit specific bug classes as a Metasploit exploit, patterns of how you use the framework and how you leverage it and how you write it in Ruby do repeat, and that's perfect for an agentic approach, especially a skills-based agentic approach, which Jonah was talking about. So yeah, it's really effective. It saves a lot of time, and it's a good way to do it.
We got to get Spencer back on here, because I got a question for Spencer. I want to know can we leverage AI to completely rewrite Metasploit not in Ruby? Because that would just. Why
would you want to do that? No.
I'm so tired of dealing with this Ruby thing. But on Metasploit,
I would push back against that very hard.
Well, I guess it is an institution.
It's going to be two forks. It's going to be a Stephen fork and
yeah, it'll be me and the Metasploit team holding on to Ruby for dear life, I think. But,
hold on Ruby forever. There you go. All
as long as it's not Python, I think it'll be okay.
Here we go. Now we're going to have the battle of the languages. Should we do it in Go? Should we do it in Rust?
That I could live with Go or Rust. That might be something.
All right, you heard it here first. Steven's endorsing doing it in Go or Rust for the migration for the Metasploit team. We'll have to see what Spencer thinks of that if we get a chance to get him back on. But hey guys, this is a really awesome find. I think it's fantastic. Obviously I'm biased, but Rapid7 willing to do this type of work to ensure that we are finding these vulnerabilities so they can get patched, and then we end up discovering that it's been exploited in the wild. So fantastic research. We're going to keep doing this stuff here at Rapid7, and I can't wait to talk about the next 0 day or the next vulnerability that we help to get patched in the industry. Stephen, thank you for your time. Jonah, you're always here, so I don't have to thank you, but appreciate you coming on and joining the war room. And that's a wrap for this segment, and we'll see y'all next time.
Awesome. Thanks, everybody. Appreciate it.
All right, welcome to the Mitigation Minute. This is the last segment of our podcast where we like to try to point out solutions, or at least help you think through what the current news is and what we can do to prepare ourselves as defenders within an organization. So we're going to talk about two main things in this segment today. One being that we just got off the War Room segment talking about the Cisco 0 day. And I think what's interesting to start with in this is a string of vulnerabilities. I briefly mentioned that previously, but there's been 6 SD-WAN Cisco vulnerabilities in 2020 around the SD-WAN software. And, Jonah, definitely, the advice is always going to be to patch. I think everybody knows that. But one of the things that I'll point out here is that patching is probably not enough in this case, because if a threat actor like UAT 8616, which has been noted to leverage this vulnerability, has indeed gotten persistent through one of the other 5 or this 6th one here, patching itself isn't going to get them out, right? And so you really want to make sure that you kind of yes, obviously do the patching. That's obviously paramount and course number one, but really recommend running some threat hunts, specifically targeting the indicator compromises that have been published for this. Cisco has put them out. Other organizations have put them out as well, because the principle here is the adversary's campaign can outlast your patch cycle. And so you've got to shift from looking at a reactive remediation to kind of this continuous monitoring, architectural constraint kind of concept. Jonah, anything to add to that?
I mean, just to mention, we didn't add them to the recent 0-day blog that we did, but if you check the attacker KB analysis of the end day that we analyzed, the first auth bypass, there are some IOCs on that as well. So normally once you, in both vulnerabilities, once you get past the auth bypass, you're using that message type 14 to add the SSH key to the authorized keys. So there are some things you can check, obviously, for unknown SSH connections coming through for that specific VM admin managed user. There is also, I think, if the peering event has a null IP address, just all zeros, is also an anomaly. Although it's not guaranteed, they could craft the exploit in a way that might not show. But yeah, you can definitely check on the original attack KB analysis for some useful IOCs.
Absolutely. And kind of one of the things you're talking about, anomaly detection, also any type of route redistribution that suddenly appears on your network would be something that I would definitely investigate. That's not noise. That's more a signal, right? That there may be something that is awry related to potentially these Cisco days, 0 days. All right. The other thing, Jonah, to step away from Cisco here from a minute, we talked a lot about the different impacts of the AI algorithms looking for vulnerabilities. And I know that not every single application company out there is as impacted as the others, and some have some really good recommendations on how to keep coding secure. What have you been able to find to help defenders think ahead for these AI algorithms looking for vulnerabilities?
So yeah, one thing I want to just share again, I'm just going to share a link. You might have seen this. We've talked quite a bit in this podcast about Mythos, obviously XBow, and also Cloudflare. Really bigging it up, saying they've had some great results from it. But there was also a bit of a contradiction to that, which was from Curl. They did get access to Mythos, and it found a single vulnerability. I think
just one.
Just one. There was some
one
bugs.
Vulnerability in one line of code. You're saying one vulnerability in all of curl.
Yeah, and it's a low severity CVE as well. It's not been issued yet, but don't be expecting anything mind blowing from it. So this is a great article to read. And the reason we're talking about this in the Mitigation Minute is because the people who are behind curl take security very seriously. They're very well known for their bug bounty program because they publish all the reports that come through, which is these days mostly slop. So they get quite a lot of attention for some of the kind of funny and somewhat embarrassing reports that they get through. So yeah, one thing that I really want to show here anyway, they talk about why they only found one vulnerability. And really it's because, yes, they've been using AI themselves. They've been using Copilot and the Opus models and stuff like that. And they've been finding vulnerabilities. I think they said here that past 8 to 10 months or so, they found several CVEs, probably a dozen or more CVEs. So they are on this, but despite how good we've heard that Mythos is, They've applied it to curl, and I'm going to show this graphic in a second, but I just want to mention as well that there's 178,000 lines of code, not including blank lines in curl. So there's a serious surface for them to find valid vulnerabilities there, right?
A legit repo of some serious code.
In fact, I think they said somewhere the size of curl, it is 660,000 words, which is 12% more than the entire English version of the novel War and Peace. So
I like the comparison.
Some really nice stats here. On average, every single production source code line has been written and rewritten 4.14 times. Yeah, so some really cool stats. They've got 188 CVEs altogether. But yeah, I just think it's really cool that they take security so seriously that, they're obviously, code style, code audits, API, private security reporting. They have a whole system built up on what they need to be looking into, what precautions they need to be taking. And I guess if more companies, particularly with an open source company as well, right? So they're getting hit by loads of AI reports. They have a bug bounty program, and they're just a really well known piece of software that's going to be like targeted a lot. So yeah, for them to have this kind of like security stance, and I guess the proof's in the pudding. One vulnerability,
and it's a low vulnerability at that. I think really this just speaks to, as we like to hype up and overemphasize, in my opinion, all these models finding all these vulnerabilities. Really, what we need to be thinking about is that's a symptom of the problem, and I think that's really what Curl points out here in a positive manner. How do you want to combat all the AI models finding all these vulnerabilities? How about start doing the same secure coding practices that we've talked about for 20 years? And look, it works. I think Curl is a model of that. It's not that they've never had a vulnerability. I think you said the stat was 188 or something like that vulnerabilities in times. But by putting in these methodologies that aren't groundbreaking, right? I mean, they're doing things like fuzzing. They're doing things like unit testing. They're doing things like, hey, let's not do git force pushes. Let's make sure that, we've got 2FA enabled for committers. Like these are foundational things to both open source, to both good code hygiene, things like that. And that proves that it works. So I think we need to put a little bit more emphasis on, instead of saying, oh, all the AI models are going to find all the bugs in all the code repos, maybe we need to put a little bit more emphasis on, hey, let's focus and really dig in now that we have a clear need above and beyond what we had before for secure coding and good secure hygiene. And that's going to help alleviate the problems that we keep running into. Anyway, that's Doug's 2 cents. Anything to add there, Jonah, before we wrap this up?
No, I think you nailed it.
All right. Well, it was another great episode. We hope that we're able to provide you something that is interesting. Please do like and subscribe and comment in YouTube. And don't forget, we are also now on Spotify, if that is your preferred platform to listen to. But of course, for all the screen sharing, that's going to be on the YouTube side. So till next time.